I hope you all are fine. Okay students, in the last lecture we have seen some basic concepts of differentiation and standard formula of derivatives, then rules of differentiation, concept of composite function and composite rule or chain rule. Now in this lecture we have to see derivatives of composite function or derivatives of some standard composite functions. Now we see derivatives of some standard composite functions. Derivatives of some standard composite functions. Now number first, dy dx of f of x bracket raised to n. Here f of x is a composite function, this is power function. Now derivative of this is n into f of x bracket raised to n minus 1 into f dash of x. Then number second, dy dx of under root of f of x is equal to derivative of this 1 upon 2 into under root of f of x into f dash of x. Number third, dy dx of, that is derivative of function e raised to f of x with respect to x is equal to e raised to f of x into f dash of x. Number 4, derivative of function a raised to f of x, which are exponent functions. Derivative of this function a raised to f of x is equal to a raised to f of x into log a into f dash of x. Now further, next function is logarithmic function, logarithmic composite function, dy dx of log of f of x, log of f of x is equal to 1 upon f of x into f dash of x. Okay. Now next functions are trigonometric functions. Number 6, dy dx of sine of f of x. Derivative of composite function sine of f of x is equal to cos of f of x into f dash of x, into f dash of x. Number 7, dy dx of cos of f of x is equal to minus sine of f of x into f dash of x. Further, number 8, dy dx of tan of f of x, tan of f of x is equal to derivative of tan of f of x is sec square of f of x into f dash of x. Next function, next trigonometric function, dy dx of sec of f of x. Trigonometric function as well as composite function. Derivative of this function is equal to sec of f of x into tan of f of x into f dash of x, f dash of x. Further, number 10th, dy dx of cot of f of x, cot of f of x is equal to minus cosec square of f of x into f dash of x. Number 11, dy dx of function cosec of f of x, cosec of f of x is equal to minus cosec of f of x into cot of f of x into f dash of x. Now these are the derivatives of some standard composite functions. Using these formulae or standard formula of composite functions, we can find the derivative of any composite function. Now we see some examples on derivative of composite function. Now here all these functions, composite functions, are obtained by simple functions. We know that x raised to n is a simple power function. X raised to n is a simple power function. Now composite function of power function is obtained by replacing x by f of x. Replacing x by f of x, that is we get here f of x raised to n. This is a composite function. F of x raised to n is a composite function. This is a simple function and this is composite function. Therefore every composite function is obtained by simple function by replacing x by f of x. Okay. Now derivatives of composite function also obtained by derivatives of standard functions by replacing x by f of x into f dash of x. Okay. Now we see some examples on composite functions or derivatives of composite functions. Now examples are: example, differentiate the following functions with respect to x. Differentiate the following functions with respect to x. Now we see some examples here. Number first, x cube minus 2x minus 1 bracket raised to 5. Second function is under root x square plus 4x minus 7. Under root x square plus 4x minus 7. Number third function is under root x square plus under root x square plus 1. X square plus 1. Number fourth, cos of in bracket x square plus a square. Cos of x square plus a square. Number fifth example, log of tan of x by 2. Number 5, log of tan of x by 2. Now we see answers of these examples one by one. Now answer for first. Consider y is equal to x cube minus 2x minus 1 bracket raised to 5. Now this is the composite power function. Okay, we have to find derivative. Therefore differentiate with respect to x. Then we can write derivative of y dy by dx equal to derivative of this d by dx of in bracket x cube minus 2x minus 1 bracket raised to 5. Okay. Now here suppose this term x cube minus 2x minus 1 as x. Treat this as x and then find the derivative of x raised to 5. Derivative of x raised to 5 is 5 into x raised to 5 minus 1. Derivative of x raised to 5 is 5 into x raised to 5 minus 1. That is 5 into x raised to 4. Okay. But here instead of x cube minus 2x minus 1. Therefore derivative of this term can be written as in the form 5 into x cube minus 2x minus 1 bracket raised to 5 minus 1 into derivative of x cube minus 2x plus 1. Okay, this is the composite function. Suppose this has f of x, then we get f of x raised to 5, and we know that derivative of f of x raised to n is n into f of x raised to n minus 1 into f dash of x. Therefore, here derivative of x cube minus 2x minus 1 bracket raised to 5 is 5 into x cube minus 2x minus 1 raised to 5 minus 1 into dy dx of this term, x cube minus 2x minus 1. Okay. Now further, we can find derivative of this term. Therefore, dy by dx as it is equal to 5 into x cube minus 2x minus 1 bracket raised to 5 minus 1 means 4 into derivative of this term. Derivative of x cube is 3x square minus derivative of 2x is, derivative of 2x is, 2 is constant term and derivative of x is 1. Therefore, we can write here 2 minus derivative of 1 is 0. That is, finally we get here dy by dx. dy by dx is equal to 5 into x cube minus 2x minus 1 raised to 4 bracket raised to 4 into 3x square minus 2. 3x square minus 2. This is the derivative of first function, x cube minus 2x minus 1 bracket raised to 5. Derivative of this function is 5 into x cube minus 2x minus 1 bracket raised to 4 into 3x square minus 2. Okay. Now we see answer for second example, which is under root x square plus 4x minus 7. For second example, let y is equal to under root x square plus 4x minus 7. Okay, this is the root function under root x. Differentiate this with respect to x. Differentiate with respect to x. Therefore, derivative of y is dy by dx. Derivative of y dy by dx equal to dy dx of under root x square plus 4x minus 7. Okay. Now for finding the derivative of this function, suppose this term as a u, then we know that under root u means under root x, and derivative of under root x is 1 upon 2 into under root x. But this is a composite function. Derivative of this function is dy by dx is equal to 1 upon 2 into under root x. But write down here, instead of root x, we write here under root x square plus 4x minus 7. Under root x square plus 4x minus 7 into dy dx of this term, x square plus 4x minus 7. Okay. Now first term as it is, this term 1 upon 2 into under root x square plus 4x minus 7 as it is. Therefore, we can write here dy by dx is equal to 1 upon 2 into under root x square plus 4x minus 7 into derivative of this term. Derivative of x square is 2x. Derivative of 4x, 4 is a constant term. Derivative of x is 1 minus derivative of 7 is 0. Therefore, derivative of this term is 2x plus 4 minus 0. That is, we can write finally dy by dx is equal to 2x plus 4 upon 2 into under root x square plus 4x minus 7. This is the derivative of given second function, under root x square plus 4x minus 7. Okay. Now we see answer for third example. Now third example is a double composite function. Third is a double composite function. Therefore, we have to use this rule 2 times, composite rule here. Answer for third. Consider or let. Consider y is equal to under root x square plus under root x square plus 1. Okay, differentiate this with respect to x again. Differentiate with respect to x. Therefore, similarly, derivative of y is again dy by dx equal to dy dx of under root x square plus under root x square plus 1. Okay. Now in this example here, suppose this term, this underlying term x square plus under root x square plus 1 as x. Then we get root x, and derivative of root x is 1 upon 2 into root x. But here we can write instead of root x under root x square plus under root x square plus 1. Therefore, into derivative of this term, that is 1 upon 2 into under root x square plus under root x square plus 1 into dy dx of this underlying term, that is x square plus under root x square plus 1. Okay. Now here, this is the addition of two functions. Use here addition rule. Take derivative of x square separate plus derivative of this term. That is dy by dx is equal to first term as it is 1 upon 2 into under root x square plus under root x square plus 1. Okay. Into, we have to find the derivative of this function. Derivative of x square is 2x. Derivative of x square is 2x plus derivative of this function. You can write here dy dx of under root x square plus 1. Now this is again a composite function. Under root x square plus 1 is a composite function. Now suppose this x square plus 1 as x again, then that becomes under root x, and derivative of under root x is again 1 upon 2 into root x. But here we write instead of root x under root x square plus 1. Therefore, dy by dx is equal to 1 upon 2 into under root x square plus under root x square plus 1 into in bracket 2x plus derivative of this term 1 upon 2 into root x. But here write 1 upon 2 into under root x square plus 1 into derivative of this underlying term dy dx of x square plus 1. Okay. That is, further we can write dy by dx is equal to 1 upon 2 into under root x square plus under root x square plus 1 into 2x as it is plus 1 upon 2 into under root x square plus 1 as it is into derivative of this term x square plus 1, derivative of x square 2x plus derivative of 1 is 0. Okay. Now here 2 upon 2 cancel out. Now remains only finally dy by dx is equal to dy by dx is equal to in bracket 2x plus 1 upon x upon under root x square plus 1 upon this term 2 into under root x square plus under root x square plus 1. Okay, now if we take here addition, then we can write dy by dx is equal to, take x common here, x into in bracket, then take addition, 2 into this term under root x square plus 1 plus upon 1 here, 1 into x upon this term as it is, 2 into under root x square plus under root x square plus 1 into this term under root x square plus 1. Now this is the final answer for the third example. Now we see fourth example, derivative of cos of x square plus a square. Now this is a trigonometric function, and cos is a trigonometric function. If we take simply cos x, then this is a simple function, but here cos of x square plus a square. Now this is the composite trigonometric function. For fourth example, consider y is equal to cos of x square plus a square. Now this is trigonometric composite function. Differentiate this again with respect to x. Derivative of y is dy by dx equal to, here write down d by dx of cos of x square plus a square. Now here also this term x square plus a square. Suppose this term as x, then we get function cos x. Derivative of cos x is minus sin x. Write down here, minus sin of, instead of x we can write this underlined term x square plus a square into derivative of underlined term d by dx of x square plus a square. Okay, that is dy by dx is equal to minus sin of x square plus a square into derivative of this term. Here use addition rule, derivative of x square plus derivative of a square. A square is a constant term. Derivative of x square is 2x. By using formula x raised to n, derivative of x raised to n is n into x raised to n minus 1. Therefore, derivative of x square is 2 into x raised to 2 minus 1, that is 2x, plus derivative of a square, which is a constant term, is equal to 0. That is, finally we can write derivative of cos of x square plus a square is dy by dx is equal to minus sin of x square plus a square into 2x. Okay, this is the simple composite trigonometric function. A simple example, this one. Now last example, example number 5, log of tan of x by 2. Answer for fifth number, or fifth. Again consider given function as y. That is, y is equal to log of, in bracket, tan of x by 2. This is also a double composite function. How to find derivative of this function? Now differentiate with respect to x. Derivative of y is dy by dx. dy by dx is equal to, now this is composite function again. Suppose this term as x, then we get log x, and we know that standard formula, derivative of log x is 1 upon x. Therefore, we can write here derivative of log of tan of x by 2 is 1 upon tan of x by 2 into derivative of tan of x by 2. Okay, 1 upon tan of x by 2 into dy dx of tan of x by 2. Okay, now further dy by dx as it is equal to this first term also as it is 1 upon tan of x by 2 into, here also this is composite function. Suppose this term x by 2 as x, underlying term as x, then we get tan x, and we know that derivative of tan x is sec square x. Okay, therefore derivative of tan x by 2 is sec square x by 2 into derivative of x by 2, that is sec square x by 2 into dy dx of x upon 2. Okay, now further dy by dx is equal to dy upon dx equal to 1 upon, we can write here tan x by 2 means sin x by 2 upon cos x by 2. Tan x by 2 means sin x by 2 upon cos x by 2 into sec square x by 2 means 1 upon cos square x by 2. 1 upon cos square x by 2 into derivative of this x by 2. X, derivative of x is 1 by 2 into derivative of x. Therefore we can write here 1 by 2 into 1. Derivative of x is 1. 1 by 2 into 1 means 1 by 2. Okay. Now here dy by dx equal to, taking reciprocal of this denominator term, we can write cos of x by 2 upon sin of x by 2 into 1 upon cos square x by 2 into 1 by 2. That is here 1 cos x by 2 cancel out, cos x by 2 upon cos x by 2 cancel, remains only dy by dx is equal to 1 upon 1 into 1 into 1 upon 2 into sin x by 2 into cos x by 2. 2 into sin x by 2 into cos x by 2. And we know that 2 into sin x by 2 into cos x by 2 is equal to sin x. We know that formula 2 into sin theta by 2 into cos theta by 2 is equal to sin theta, or 2 sin theta into cos theta is equal to sin 2 theta. Okay, now here we use this formula 2 into sin theta by 2 into cos theta by 2 equal to sin theta. Therefore 2 sin x by 2 into cos x by 2 is equal to dy by dx is equal to 1 upon 2 into sin x by 2 into cos x by 2 equal to sin x. Sin x. And again we know that 1 upon sin means cosec x. Cosec x. That is derivative of function y equal to log of tan of x by 2 is equal to cosec x. Okay. Now see one more example. If we ask only one example in examination, ask like this: differentiate y is equal to, differentiate y is equal to 5 raised to sin cube x plus 3. 5 raised to sin cube x plus 3. Now answer for this example. Differentiate this equation again with respect to x. Differentiate with respect to x. Therefore derivative of y, dy by dx equal to dy dx of, in bracket, sin raised to 3x, dy dx of, in bracket, 5 raised to sin cube x plus 3. Okay. Now this is the exponential function a raised to x. Suppose this underlying term as x, then we get 5 raised to x. 5 raised to x means like a raised to x, and we know that derivative of a raised to x, dy dx of a raised to x is equal to a raised to x into log e. Using this formula, we can write derivative of this function dy by dx is equal to 5 raised to x, that is 5 raised to sine cube x plus 3 into log 5 into dy dx of this underlying term sine cube x plus 3. Okay, that is dy by dx is equal to 5 raised to sine cube x plus 3 into log 5 into d by dx of this sine cube x can be written as in the form sine x bracket raised to 3 plus d by dx of 3 by addition rule. Now further, from equation first, 5 raised to sine cube x plus 3 means y. Put this value here, then we can write here dy by dx is equal to y into log 5 into derivative of this term. This is again composite function. Suppose this sin x as x, then we get x cube. Derivative of x cube is 3x square. Okay, therefore we can write here 3 into sin x raised to 2 into d by dx of sin x plus derivative of this constant term is 0. Okay, that is dy by dx is equal to y into log 5 into in bracket 3 sin square x. Now this is simple function. Derivative of sin x is cos x. Derivative of sin x is cos x. Now finally we can write here dy by dx is equal to 3y into log 5 into sin square x into cos x. Now this is the answer for the given example. Derivative of 5 raised to sine cube x plus 3 is equal to 3 into y into log 5 into sine square x into cos x. Okay, we will stop here.